covered almost anywhere that I can find. What it represents is on a hill, it is the path that something that's falling will accelerate the fastest. So it's the fastest way to get down the hill if you're being pulled by gravity. And so skiers pay a lot of attention to this because they actually ski back and forth across the fall line. If you drop a ball, it will fall down this way. But where it's significant for geology is it is the path that a flood would take, or contaminated water, or a landslide, or a lava flow. So it is a way to predict where hazards will end up being in some of these cases. There are 3 rules, basically, to follow when you're constructing these. The first one is that we will always start at a higher altitude and we fall downhill. You are not falling uphill ever. So that's a pretty easy a rule to remember. By extension, you don't stop until you get to your lowest altitude that's on your map. Often, that's represented by a depression or a lake. It could also be a river or an ocean. So where if water flows in, once it flows into a body of water, don't make it come back out. Just assume that's the lowest level that it goes to. The second rule is always the most confusing to people. You're going to minimize the distance between topographic contour lines. So if I am at this point, I want to select the path that will minimize this distance. And then, once I'm here, I look at the next path that would minimize that distance. And the third rule is wherever it crosses the topographic line, it will cross at a 90-degree angle. So, I'm going to start at A, and I'm going to use a red marker to sort of demonstrate that. If I am at A, and I just visually look at that, the shortest distance to the next contour line looks to me to be about there. And what I'm going to do is make a tick mark so that the mark crosses the contour line at a right angle. Now I'm going to ask myself, what is the shortest distance to the next contour line? To me, it looks like it is about here. And again, I'm going to make the mark with a right angle. From here, I have a little bit of a harder choice. It's not going to come straight across because that's a large distance. Instead, it looks to me to be about right here. And I'm going to make my perpendicular line through that contour line. So now you can see that the fall line is going to have a curve to it somewhere. From here, it looks like my shortest distance is there. And then finally, I'm going to go into my depression. And the last step is to connect those with a smooth line. And I always add an arrowhead at the end. And you'll see that in order to make those lines perpendicular, in between contour lines, your flow will have to change directions and make a nice path. If you run into problems with this when you start working on them, flag me down because this is, like I said, this is tested several times in this class. Questions? Okay, cool.